Hi again, folks. So I just wanted to record an extra little bonus video once again, just to provide a little bit of extra help in this graphing unit and show you some additional things that can be helpful on a website called Desmos. So some of you might have used this website before, maybe in grade 9 or even with previous teachers before that. And it has lots of different tools you can use for all different sorts of graphing. It's essentially just like an online graphing calculator that can do a lot of things for you. But it also can let you play around with the equations of certain quadratics and other things and explore them a little bit. And so I wanted to just show you some of the things that you can do. So first off, you'll just need to go to desmos.com. I'll also mention that everything I'm going to be showing you in this is fully accessible on the app version of this as well. So if you're doing this on your phone or on some sort of other tablet, the app version of this will still be able to access everything that I'm going to show you as well. So you can even download the app version by first going to desmos.com or just by buying it in the App Store or the Android store from there. Now, once you're in, if you just go to Start Graphing, that's what's going to take you to the main graphing area, the main graphing calculator section. There are some other activities that can be done, but for now, we're just going to focus on that and see how we can use that. Now, I will show you how we can use this to do some of our own graphing if we want to. And in a minute, I'll show you how you can use this if you don't have your own graph paper and you aren't able to print off the grids that we've provided in the notes, but you still want to do some of the same skills that graphing by hand allows you to practice. I'll show you how to do that a little bit later in this video. But there's some other really cool features that I wanted to show you first. So first of all, this space here is somewhere where if we already knew the equation of something that we wanted to graph, we could type the equation right in here. And there's some other things that I'll show you later on. But another thing we can do is actually look at this area off to the side, and they give us a whole bunch of graphs that are already created for us that we're allowed to play around with a little bit. And so the first few are ways that you could play around with straight lines. So these are things that you might have even played around with a little bit in grade 9. But we're going to focus, of course, on parabolas. And what I really want us to understand, the most important thing to understand after this course, is how the vertex form of a parabola really works. So I just click on that, and I can open up the graph, and you can open this version up for yourself as well. So now, what it's done for me is it's first written out the general equation, and then what it's actually set up for us is essentially sliders, or things that allow us to click and adjust what the A value, the H value, and the K values are. And then you can literally, on the graph, see what effect it has. Now, I'll also mention while I'm here that just if you want to make this a bit clearer to see, you can change the scale, because in this default setting, it's showing that all of our X and Y axes are marked off every other square. But if you want to show one grid line, you can just go to this graph settings icon here, which is the little wrench. And then for X axis and Y axis, you can click on step. And I'm just going to make the step 1 and 1, so that now when I click off and go to my regular graph, I can see that every marking is clearly identified, and it allows me just to find my points a little bit easier. But now, if you want, you can play around with these sliders. And so I'm going to use them to prove to you the things that I've been saying all along. So first of all, the A value. Well, let's stick first with positive A values and see what they do. An A value of 1 creates what this would be called the basic parabola shape. But of course, if we get larger and larger positive A values, as we increase this to larger and larger values, the Y values jump up much quicker. And that has this effect of stretching things out vertically. But you can see what's more obvious is that it seems to squish things in horizontally. So it becomes more and more pulled from the vertical direction, and it squishes it or sort of stretches it out. If you imagine taking a big piece of Play-Doh and grabbing it from the top and bottom and stretching it out in the vertical directions, it's going to make the middle section get skinnier and skinnier. As we lower the A value, of course, the opposite happens. And we get wider and wider. And even when we go below 1, so now in this area here, I'm going, this is like a 1/2, so I'm in the region where I'm still using values that are greater than 0, still positive, which is why my parabola points up, but these would be like small fractional values in between 0 and 1. And that just makes it wider and wider. So we sometimes say compressed, kind of like you're squashing down from the top of a piece of Play-Doh to make it wider and fatter on the edges. But if we keep lowering it, eventually we end up in the negatives. And whoop, something happened very noticeably when we got into the negatives. We ended up still with a very wide-looking parabola, but now it's a negative a value. So that y, oopsie, that negative value of our parabola here is now pointing downwards whenever our a value is negative. And then again, as our a value gets larger and larger in terms of its negative value, we get a more and more vertically stretched out negative parabola. So the same effect occurs. So if I set this back to something a bit more normal, maybe like a 1, now I can play around with the h value as well. Now, these h values, keep in mind, are based on this equation, which involves x minus h. Now, I made a separate video, which if you're still a bit confused as to why there's a minus h and that's really bothering you, there's a separate little bonus video I created that tries to explain that in a bit more detail. But the idea is that these h values are being subtracted inside of the bracket. So what we notice is that if we subtract larger and larger h values, it pushes our parabola along the x-axis. And that pushing we call translating. It's what we call a horizontal translation. It is sliding it or moving it horizontally in a particular direction. And as we subtract larger and larger h values, larger positive h values are being subtracted, we get pushed farther along the x-axis. Now, what about if we're subtracting negative h values? Well, subtracting negative h values, so for example, if my h value is -2, you would actually, in the equation, end up seeing x plus 2, because it's like I'm subtracting a negative, so it's like I'm adding 2. So in the equation, we would see x plus 2, but we see the effect that that has. It actually puts our vertex point into the negatives. So our h value of -2 is telling us that our vertex point has been translated into the negatives, 2 units towards the left. The k value, well, we know what that does. If we increase the k value, it's going to take our vertex point and move it upwards. If we decrease the k value, it's going to move it downwards. And in fact, if we have a negative k value, it's going to mean that our vertex point starts way down in the negative somewhere. So you can play around with those sliders. And again, they help us to understand these things a bit better. And remember that in lesson 2, we didn't learn any new skills. All we did was make sure that you're understanding the terminology that we use for these 3 pieces of information. So for the a value, that's telling us whether or not there's a vertical reflection happening. Whether or not it's positive or negative tells us that. But it's also telling us whether or not we have any vertical expansion, that would be like stretching it out longer, or if we have any vertical compression, like squashing it down. Those are the terminology pieces that we use for that. Whereas for h and k, it's more about sliding the graph around to different places on the grid. And that sliding we actually call translating. So we either talk about h representing a horizontal translation amount, or k representing a vertical translation amount. So you're free to play around with those as much as you want. Now, I've actually just opened up the basic graphing thing in a separate tab here, just to show you what else we can use this for. So first off, I've actually typed out just a general equation, or a specific example, I should say, of an equation in its vertex form. But there's nothing special about this one. It's just a random example that I came up with. I typed it out myself, and you can type out full equations just like I have, mostly just using regular keys. So the X's and brackets and Y's, that's all just the regular stuff from my keyboard. And if you want to do something like a squared or anything else that's a bit fancy and mathematical, you can use the keypad down here. I just clicked on the a squared button after this bracket, and it made that squared. So you can play around with that and type out equations. But to actually make this equation appear on the graph, to graph this out for me, all I would actually have to do is click this little icon here, and it would appear. And if I clicked it again, it would disappear. But right now, I'm actually going to keep it hidden from you, because what I want to do is show you how you can actually use Desmos to practice graphing skills the same way that someone who's graphing by hand would be practicing. So let's say you don't have your own grid, or you don't have your own piece of graph paper to do this by hand. Well, what are the important skills that we as teachers really care about? Because we don't really expect that you're going to go on to some job someday and your boss is going to put a big piece of graph paper down in front of you and ask you to graph out a quadratic by hand. We know that that's not realistically what you'll be doing in your lives. So why do we ask you to do this in general? What is the value of actually plotting these things out by hand? Well, it allows us to visually understand and demonstrate that you understand where a vertex point should be located. And it shows that you have a visual understanding of where all of the other points connect to that vertex point and how they relate to it. And it shows that you can create the shape of a parabola and understand how that parabola connects all of the points together in the pattern that it creates. We can do all of that just using some of the tools that we have on Desmos if we don't have the actual paper to do it out point by point. And the way that we're going to do that is with a table of values. So here we can actually add an item, and one of the items we can add is a table. And now it's going to fill in X coordinates and Y coordinates, and each time I do, it's going to plot a point for me. So what I'm going to do is essentially plot out these points manually. I'm going to first look at my equation and figure out where my vertex point is, and I'm going to enter in the points and plot them bit by bit onto my grid. So here, if I have a +3 inside the brackets, that means my H value is actually -3. So I can literally just type that in. My K value is +6, so that means the Y coordinate of my vertex is 6. And you can see it plotted in green for me, a nice point at that exact vertex. So that's going to be my vertex. And now let's use the connections and relationships that we know vertex form is telling us to find the other points. Because again, that's the important skill. It's not necessarily that you have to be able to actually plot these by hand onto a piece of graph paper. That's useful, but the reason why it's useful is because it shows that you have a visual understanding of how these points connect together on the grid. So let's make that visual connection here. Well, this A value is -2, which is telling me if I want to find the next point, then I go from my vertex over to the right by 1 and down by 1 squared times 2. So I go over to the right by 1 and down by 2. I want to plot a point here. And if I was doing this by hand, then I could just plot a point here to demonstrate that I understand how these points connect. But now I'm going to do this with my Desmos feature here. So now I want to plot a point right here. So let's just tell it to plot a point there. Because this point I can see is -2 and 4. So there's going to be a point here, and I'm going to put -2 and 4 in just a moment. But while I'm at it, I might as well recognize that I'm going to have a symmetric point right about here. So I have a point here at -2 and 4, and I have a point here at -4 and 4. So I'm going to literally just put those in. -2 and 4 and -4 and 4. And hey, that plotted my 2 points here, and they are each 1 unit to the left or right away from my vertex, and then 1 squared times 2 units down. So that follows the correct pattern. How would I plot the next couple of points? Well, again, I go back to my vertex. I go over to the right by 2, and instead of going down by 2 squared, I need to go down by 2 squared times 2. So I go to the right by 2 and down by 4 times 2, which is 8. So I go all the way down to about here. This is where I want to plot a point, is down here. So again, because I can't just do that with a pencil, I'm just going to tell it to plot a point there at -1 and -2. That's the coordinates. This is also good practice in identifying coordinates. -1 and -2. But if I have a point here, then I should have a point that's symmetric with it, but is 2 points to the, or 2 grid lines to the left away from my vertex and down at that level. So that would be -5 and -2. So that's me essentially manually plotting those points. And again, that's the important skill. That is why teachers ask you to plot by hand. And if you do have graph paper, it's probably going to be easier for you to go through this process by hand. But the reason we're doing it is not because the skill of doing it by hand is essential, but because creating the points bit by bit this way demonstrates that you have an understanding of how these points connect to each other through the patterns that this equation creates. Now, the tricky part is connecting these together with a smooth curve. So I'm not going to bother to do that with this method. If you're choosing to try and graph with this method, what you can do instead is eventually, after you've done all of these points and you've plotted those points here, type out the full equation the same way that I've already done here for you. I did it early so that you could see what equation I was working with, but you don't have to do this in advance. So after you've plotted the points, type out the full equation like this. And actually, in this case, once you have it typed out, it will already appear for you. I've hidden mine right now, so I'm just going to click this and make it reappear. And if we've done this correctly, then our points should perfectly match up with the parabola that it draws for me. And you can see it perfectly does go through and connect all of the points together. And what's nice about this is it also helps to identify a few key points as well that you might be interested in. So it automatically identified this vertex for us, but we already knew that point. But if we also wanted to know what the x-intercepts are, because in this particular case, it's not nice, simple values to find, we could actually quickly identify those as well. It puts special points there and clearly identifies for you any other key points that it can identify. So those are just ways that Desmos can help you first, using this little slider tool, understand how the vertex form works, but it can also be a tool that you use to practice all of the same skills of graphing by hand, even if you literally don't have any graph paper to do that graphing by hand on. Hopefully that's helpful for you. Let me know if there's any other questions you have about Desmos and you're interested in finding out more about it.